Oh, good morning, gentlemen. Not gonna be much of a video today. I'm whooped and I think I'm gonna fuck off for the rest of the day. But I just wanted to have a little bit of update time. I've been getting ready to work on the software for that Z80 Funtime shit. And I decided to use Z88DK instead of SDCC. I'll talk about why here in a second, but I thought it would be fun to actually develop the software using this serial terminal, so I plugged a null modem cable into the back of it and went up to that USB serial cable plugged into the big bitch up there, and this terminal was working just fine when I had it connected to the proper serial port in that ProLinea. But I'm having a hell of a time getting it to operate correctly on that newer Linux box. Of course, that thing was running, that's got an honest to God like ISA based hardware serial port in it, I'm sure. And it's running Slackware 12, I think, and of course that's running the Devuan series, and it's got the USB adapter. And my supposition is that the USB serial adapter doesn't implement hardware handshaking quite right, because the serial terminal overruns the serial stream and gets all confused. So that's kind of aggravating. I'm not exactly sure what to do about that. I took the 8250 UART out of the serial terminal and replaced it with a 16550, which has a FIFO buffer on it, whereas the 8250 can only store one character at a time, hoping that would end the overruns and give like X on X off handshaking time to catch up and shit. But that didn't work either. It worked a little bit better that way, but it still got overruns and got all fucked up. So that's pretty frustrating. The motherboard in that machine does have one hardware serial port header on the motherboard, but I don't have I don't have any ribbon cable bracket, ISA bracket doohickeys to do that with that I'm not using elsewhere. So damn it. So, yeah, the reason that I'm switching to Z88DK instead of SDCC for developing the software for that board is that Z88DK supports ROM-based systems a little better. And let me tell you what I'm talking about here. So, like, C compilers C programs require some RAM. They have, well, let me draw the memory map of this machine and we'll talk about why. So, up towards the bottom of the memory map. I should probably draw these growing up from the bottom. It might be a little more straightforward, but whatever. So we've got our what was it, 8K of ROM, here that goes from 0 to 1 FFF. As I recall. I may be full of shit on that. And then we had our RAM. I'm not going to draw this to scale. Our 2K of RAM that went from 2000 up to 2800 hex, right? So, like when you call functions in C, it pushes the function arguments onto a stack. In RAM before it calls the function. That's where all of your local variables to the function go into, and it uses those variables while it's inside the function, and then when it returns from the function, it pops all of that shit off of the stack. That's how you get that scoping, that variable scoping shit going on, right? So of course we have to have some RAM to be able to do that, for one thing, and there are ways around that. We can that makes the functions re-entrant as well. You can call a function and it can call itself, and it allocates new local variables on the stack, uses them during that nested call, and then when it returns from that nested call, that shit gets popped back off the stack, and the calling function the same function still has those old variables like further down in the stack. You know what I'm saying? So that makes functions work reentrantly, and you can kind of fake that with some of these embedded systems compilers to not use any RAM. To not use any stack by making all of those variables static and then call the function that way. But then the functions aren't reentrant when you do it that way. But that's one way to avoid using a stack. But the fact remains we still have to have like initialized variable storage with a C compiler as well. Like when you define like int I equals 4 or something, that the space for that variable, like most C programs, get loaded off of a disk and executed entirely in RAM. So the compiler can be like, okay, well, here's the storage space for that variable I, and it sets it to 4, and then later in the code, like other code can change it. But that's not the case with a ROM-based system like this that has a certain amount of like non-writable memory in it, because we can't, we could declare, that variable I equals 4, but then if something else tried to change it, it'd be trying to write to the ROM, and, obviously that's not going to work. So, programs that run on ROM-based systems like that, we'll call that the heap. That's where all the static variables go, is on the heap, and then the ones that aren't allocated through function calls, the ones that aren't local to functions, go into a heap. That includes like dynamically allocated memory, and all of the shit that's like scoped within functions and shit like that goes onto the stack and gets popped on and off as program execution happens, right? So the way that a C compiler generally does this, and I may have this backwards, so I may be full of shit and leading you wrong here, but in the memory space that the C program can use, it'll define the heap on one end of the RAM, like up here. It'll put the heap up here, and it'll put the stack up here, or down here, or up here, wherever you want to call it, right? And as you allocate and deallocate things from the heap, the heap grows in this direction, or shrinks, and as you call functions, the stack grows and shrinks in the opposite direction. So there can be a condition where they meet in the middle, and everything gets fucked up. Stack heap collisions, I'm sure you've heard of them. And you run out of memory, and everything gets fucked. So in these ROM-based systems that execute like execute code that's been written in C out of ROM, what it has to do is, if you've got like initialized variables that are supposed to go in the heap, then the compiler has to include a loader in the startup code that takes all of those initialized variables that are supposed to be on the heap and copies them out of ROM into this heap space on one end of the RAM. You know what I'm saying? And then when it calls the main function, it starts up the stack down on this end, and everything works. So the Z88DK is a little better, from what I've read so far, with working with ROM-based systems like this, in that it's a little bit easier to get those loaders working with it. It does all of that shit automatically. It can just output ROM images that you can burn to a ROM. You tell your code, where your segments are, where you want your stack and your heap to be, and all this bullshit, and then it magically creates a ROM, a binary file that includes the loaders that you need to get initialized variables up into the heap and all of that bullshit. So I'm sure that there's a way to do that with SDCC as well, but it didn't look nearly as straightforward reading its documentation, so I'm kind of relearning the development toolchain, and that's why things are going a little bit slowly with the Z80 Funtime project at the moment. So that's what's going on, but I think today I'm just going to fuck off all day because I'm aggravated and tired. I will probably play Dwarf Fortress the rest of the day, which is an excellent game, and I'll have to do a promoting other YouTube channels video on a certain Dwarf Fortress YouTube channel that I absolutely love. The guy is insane and brilliant. So anyway, I'll do that some other time, though. I don't want to mix it in here. All right. I did pull a bunch of components off of that second Genesis PC board. It is bad, man. I'll do another video about that. But I was working on that yesterday, and I mean, it is corroded as fuck. I think the clock chip or the clock crystal, the main crystal, I think it got corroded up. It's not generating clocks. None of the clock generation is working on it or anything. So I'm gonna fart around like trying to put some fly wires on it and see if I can get it going. But if the crystal is fucked, I'm sure I won't have the right value to put back into it, so it'll probably just end up being used for parts. But it'll be interesting to use for like swapping the ROM and some of the cache RAM and stuff like that around. Maybe we can get it working. I don't know. We'll see. It came with a PS2 floppy drive and a 240 megabyte parallel IDE hard drive, and the motherboard and the bottom part of a PS2 Model 25286. You can tell because it doesn't have the knockout removed for the audio jack. And all of the faceplates for the disk drives, so those are kind of hard to find sometimes. And the motherboard itself, even if we can't salvage it, it's got 5 or 6 32K by 8 static RAMs on it that'll be really nice to have for various projects like this. And a keyboard controller, a PS2 keyboard controller, and all the BIOS chips and all of that stuff. So I think I was a little leery of. I paid way too much for the first one. That's all fucked up. And I didn't pay all that much for this one, considering all of the battery damage on it. But I was still kind of leery. But I think even regardless of what happens, I think it'll be useful for parts. And maybe if I can get one of them working, maybe I can send the other board to one of you guys that knows more about what they're doing, because maybe they can both be fixed. And I would hate for a cool old 5x86 PS2 Model 25 upgrade motherboard to go into the junk, just because I'm too dumb to fix it, you know what I'm saying? So, alright, bye.